All right, so let's try example number 5. In this example, we're asked to find the horizontal and vertical asymptote of the function. The first part is to first factor completely the function. So let's try to do that. So first, let's go ahead and take the function and factor it out. And by factor this out, it means the denominator, right? So because we have a difference of squares, right? That's a perfect square and that's a perfect square, and there's a difference. That means that we can rewrite it in this form. And the way we're gonna figure out this number is by maybe rewriting it this way, right? So that number is this number, and this number is this number, right? And then you just alternate the signs. Okay. All right, so we factor this out. The numerator does not require to be factored because it's just x squared. But that's pretty much it for that part. Let's determine the domain of the function. That means where is the function defined, and we can see here that it is defined everywhere except where the denominator is equal to 0. And we can see that that happens at x equals negative x equals minus 2 and x plus 2. So look at that denominator and set equal to 0, right? And solve for x. So this will happen by adding 2, x equals 2, subtract 2, subtract 2, x equals negative 2. So the function cannot be defined at 2 and negative 2. So because that will give us an undefined value. So those are the numbers that we're going to exclude. Right? So x cannot equal negative 2 and x cannot equal positive 2. For the vertical asymptote, we would have to try to cancel as much as we can, right? In this case, there's nothing we can cancel because there's no numerator that has the same factor as the denominator. So there's nothing we can cancel, so we're gonna use it as it is, right? So to find the vertical asymptote, we'll do the same thing. We'll do the same thing and set the denominator equal to 0, because that's all. To find the vertical asymptote, we have to find where the denominator is 0. But we already did that before, right? It's the same one as before because the only difference that would happen here is that if there was something we were able to cancel, then we would exclude that number that we cancel. But we didn't, so they happen to be the same. Right? In other words, if you were able to cancel something, then only the one would have been the vertical asymptote because the other one got canceled. For the wholes is again the factor that got canceled, but nothing got canceled. So no wholes here in this function. The x-intercept, as we mentioned in the previous video, is going to happen whenever y equals 0. So we're going to find x when that's true. So you take the function. Remember that f of x is equal to 0. So we're going to find out, we're going to set y equals to 0. So this is equal to 0. So we're going to find out what is the x value that will make this be 0. As I said before many times, the only way that a fraction can be 0 is going to be whenever the numerator is 0. There's nothing that this can be done. If this is not a 0, then this whole thing is not gonna be 0. So we look at the numerator and we set it equal to 0. So we take x squared, set it equal to 0. This is going to be 0 whenever actually x is 0. So the x-intercept is x equals 0. So x equals 0, y equals 0. That means the x-intercept is at 0, 0. Now, how do we determine whether this is even or odd? We look at the power. We look at the power of this 0, which happens to be 2. 2 is an even number, then that means this is even. Now, if this power would have been third, then 3 is an odd number, and so this would have been this 0 would have been an odd x-intercept. Excuse me. And let's find out the y-intercept. So y-intercept is y-intercept. That happens whenever x equals 0. We're going to find the value of y. So that happens by going back to the functions, plugging 0 for x. This will give us 0 squared, which is 0, and over negative 2 times positive 2, 0 over negative 4, which is 0. So y is 0 whenever x equals 0, which makes sense because that's the same thing we got last time. So it's the same value, right? In this case, the x-intercept happens to be also the y-intercept, right? And now let's look at the end behavior of this. Here we can just look at those two. And as x goes to infinity, infinity, and infinity, infinity squared is just going to be infinity. Infinity squared minus 4, that's nothing. That's still going to be infinity over infinity, right? So it happens to be 1. For negative infinity, it's still going to be the same thing. Negative infinity square, negative infinity square, right? They're both going to become positive. Positive minus 4, positive infinity over minus 4 is still infinity. So this is infinity over infinity, still 1. So y equals 1. That's going to be your horizontal asymptote. And then lastly, what we're going to do is we're going to plug in the functions. We're going to plug in the information that we got. So in the first one, we got a vertical asymptote at negative 2, positive 2. And then also a horizontal asymptote at y equals 1. And let's see, why is this? There you go. So this is x equals negative 2, x equals 2, y equals 1. Now, do you guys remember that we also had an x-intercept? That's going to be a point on the graph, right? Y at x equals 0, y equals 0. Because that was even, that means that this is going to be bouncing off. Bounce from the point, right? So that means it's going to touch it and it's going to bounce back. Now here, what we're missing is knowing what happens here, 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 right? But remember that this is supposed to be a function, so it's either going to be here or here. It's going to be here or here, but not on both top and bottom, right? So we have to decide where this is going to be at. To do that is as simply as just plugging a point on the graph. So I'm going to plug in -3 and +3. So into the function, let's figure out what happens when x equals -3. That's going to give us -3 -3 square over -3 square minus 4. Right? This is from the original function, x squared over x squared minus 4. This gives us 9 over 9 minus 4, which is 9 over 9 fifths, right? So this is going to be somewhere around here, right? Fifth. So that'll be less than 2, so somewhere in here, that point is going to be. We'll do the same thing for f of 3, and you're going to get the same result. 9 over 5, which means it's going to be somewhere in here. This means that the graph has a point on this side, and it's going to go down, and then also a point on this side. And it's going to go that way. Okay, kind of smooth, right? So that point right there is going to be 3 9/5, and this point is -3 9/5. Now, if that point would have been down here, then the graph would have been down there, right? But we know that the point is above 1, right? Because 9/5 is greater than 1, so that means it's above the horizontal asymptote. So there you go, right? Again, if that point right here would have been down here, then we would have drawn the graph over here. And there you go.